Okay, we're going to go over Unit 7 test as a preparation for the semester test. There will be problems like this on the semester test day 1. So let's go through each problem rather quickly. We got angles LMN and NMP. There's LMN going that way and LMP coming out that way. So we've got them highlighted in yellow. Let's take a quick look. Let's say, are we vertical angles? Well, vertical angles, we're looking at this guy right here. Are they vertical? No, they're not. They're not two lines and opposite angles of where two lines cross, so it's not a vertical angle. Is it an adjacent angle? Well, yes, it is. Those two angles share a side. NM, ray N, MN, ray MN is their shared side, so they are adjacent. Are they complementary? Well, complementary means 90 degrees. So if they're complementary, that means they add up to 90 degrees, and this little square means that those two add up to 90 degrees. So yes, they're checked here, adjacent and complementary. Supplementary is 180. Well, we already know they add up to 90, so they can't be supplementary. So let's go on to the next one. Let's take a look at JMG and PMK. JMG, PMK. All right. Are they vertical angles? Well, right away we see that they are the opposite angles of two lines crossing. So yes, they are vertical angles. Are they adjacent? Nope, they have to share a side, so vertical angles can't be adjacent. Are they complementary? Do they add up to 90? Well, we don't know. They might not. We don't know, so we can't say they are. And do they add up to 180? We also don't know, so we can't call them a supplementary either. Now let's take a look at number 3. Number 3 says, let's do it in blue here. If angle JMG is 39 degrees, so let's label JMG as 39 degrees, and the measure of angle LMN is, how much do they say? 72. So 72 degrees. Find each angle measure. So angle JMK, we'll put that one here. Let's go with yellow here. Not yellow, that is red. JM. What color are we doing? GMK. There we go. I gotta get my letters correct. GMK, and let's make that a little smaller. Okay, so the highlighter G, where's G at? Right here, MK. Well, the first thing I see is that is part of a flat line. So we know that is all the way. The flat line is 180. So we can subtract 39 to get that one, and we subtract 1, borrow the 117 for 141. So that's how we get 141. Okay, let's take a look at PMK in yellow. PMK in yellow. So PMK is PMK. Well, what do we know about it? We know that it is vertical with JMG, so its vertical partner is this guy right here. These two are vertical partners. So they're the same degree as each other, and that's where we get the 39 degrees, because angle JMG is also 39 degrees. And finally, let's look at NMP, and that's this little one right here, up here at the top, NMP. Well, we know that this is 90 degrees, so 90 minus 72 leaves us with 18, and there's our 18 degrees. Given the diagram below, which statement is true? Let's take a look at each statement. Angles 1 and 2 are vertical angles and supplementary. No, they are not vertical angles, so that's a no. Okay? Angles 2 and 3. Well, 2 and 3 are these two. They are not complementary, they're supplementary. So we can get rid of that guy right away. Angles 1 and 3. Well, 1 and 3. Well, we know they're vertical. They're vertical angles and congruent. Vertical angles are congruent, so we know that that guy is good. And then we finally, let's take a look at 2 and 4. There's 2, there's 4. They're also vertical angles, but we don't know if they're supplementary. Supplementary, they may be supplementary, but we do not know if they add up to 90 degrees because nothing in that diagram tells us that. They are congruent because they are vertical angles, but that one is not a option. So C is our answer. Number 7, if angle A, we're supposed to come back up to, this is just no drawing. If angle A is and B are supplementary. Supplementary is what? 180 degrees. And B is 54. We just have to do exactly what they did here. 180 for supplementary, subtract the 54, that gives us the 126 for the measure of angle A. How about this guy? Solve for X. Well, we've got 2 vertical angles, so we can set their algebraic equations together. Notice that X is not the degrees here. X is a variable inside of a formula that tells us the degrees. So having 7x plus 3 and 10x minus 24, they don't show it to you right here, but they're subtracting 7x from both sides. So I can kind of draw it in there, 7x minus 7x. That leaves you with your next line here of 3 equals 3x minus 24. They're going to subtract 24 from both, or add 24 to both sides. Add 24 to both sides. That leaves you with 27 equals 3x. Then they divide by, whoops, wrong one. Divide by 3, divide by 3, and that gives you your final answer, x is equal to 9. Once again, that is not degrees answer, that is just the x inside of the degrees angle. Next, number 9 is the same kind of problem. We recognize that these two are supplementary, adjacent, so they make up 180 degrees on that line right there. Their shared side is this guy right here. So since they're 180, we just set their 2 equations. The first equation, 6x plus 10, and add it to 7x plus 8, and we set it equal to 180. So you add those two, you have like terms here and here. There's the like term here and here. That adds up to 13x, and negative 10 and positive 8 give you a negative 2. Still equal to 180. We add 2 to both sides, so 13x is 182. We divide by 13, x equals 14. Now we're given the measure of angle P is this equation in degrees, and the measure of angle Q is this equation in degrees. P and Q are complementary angles, okay? Complementary means they add up to 90. There's our 90. There's our 2 equations, okay? Now notice that they're asking us to find the measure this time. They're not saying find the value of x, they're finding the measure. So we have to solve for x. We do our like terms again. We have 12x and 6x gives 18x, and 7 and negative 7 cancel out to 0. 18x equals 90, and then we divide by 18 and we get x equals to 5. That's not our final answer. We then have to substitute that 5 into one of our original equations, the one specifically for the measure of angle Q, which is 6x minus 7, where we put x as 5. That gets us 30 minus 7, which gives us our 23 degrees. And there is our final answer, 23 degrees, because they're asking for the measure of angle Q. Fill in the blanks. Angle 5 is corresponding, okay? So let's take a look at our transversal. This is the T, the transversal. These two are parallel number 1 and parallel number 2. So for corresponding angles, they'll be in the same position inside of this pattern. And this inside of that pattern, it's the upper right. So the same position is number 7, and that's what we got. Now we're looking at number 8, alternate exterior. Let's take a look at alternate exterior with number 8. Okay, there's exterior. So alternate means it has to be on the other side of the transversal. So it's got to be on this side of the transversal now, and it's got to be exterior. So there's the alternate exterior, number 1. 3 and 6, alternate interior. So now we're looking at alternate interior angles to number 3. So let's take a look at number 3 in red. There's 3. What's the alternate mean? Opposite sides. So we got to be on this side of the transversal, and the opposite interior, it's got to be interior. So there's number 6. Now they're looking at what one is consecutive interior with number 7. So I'll circle that in green. There's the number 7. And consecutive interior means the same side and interior. So there we are. Okay. Now they tell us the measure. I'm going to erase everything over here. Now they tell us the measure of angle 4. And they tell us that it is 122. So we know this is 122. Let's make that a little skinnier. Okay, and let's erase that and write that as 122. 122 degrees. Find each angle measure. Okay, well, it's very simple. We go from 4 to 7 are vertical, and 2 and 5 are corresponding. 2 corresponds to 4, and 5 corresponds to 7. So those are all going to be 122 degrees. And I didn't mean to erase that, 122 degrees. So those are all going to be 122. So if we look at it, we need angle 2 to be 122 degrees, angle 5 to be 122 degrees. We already know that angle 4 is 122 degrees, and finally angle 7 has to be 122 degrees. Now we calculate these two. We know that 4 plus 8 has to equal 180. So we just subtract the 22 from that, 122 from that, and that tells us that angle 8, and I'm going to change to orange, angle 8 is 58 degrees. So the orange ones all are going to be equivalent, and they're all going to be 58. Now we're asked to find the value of x. The first thing we notice is that this angle and this angle have to be somehow related, and they are as alternate interior, and alternate interior angles are congruent. So we set the two equations equal to each other. We do our manipulation of, let's see, what do? We subtract 8 in this first 8x from both sides. We end up with 2x minus 29 equals 3. We then add 29 to both sides, get 2x equals 32, x equals 16. Number 17, find the value of x. Now, notice these arrows. I think some people got confused. That means that we're talking about these two interior angles, and they're consecutive interior. Consecutive interior are add up to 180, because if you think about it, let's take a look at this guy. Let's just call him angle Z. If he's Z, that's a bad Z, but if he's Z, his alternate interior partner is also Z. Okay? And look at this. That line right there is supplementary. So these two angles have to add up to 180. So since this and Z are equal, we can just set both of those equations, add them together, and set them equal to 180. And after you add them, the like terms together, then subtract out the numbers, then divide by 18, you end up with x is equal to 11. Excuse me. Now let's take a look. We know the measure of angle 3 right here is 9x plus 14 quantity degrees, and the measure of angle 5 right there, which looks to be a corresponding angle, correct, is 14x minus 1. So since they're corresponding angles, we can set those two variables. Once again, we're not finding x anymore. We're finding the measure of angle 8. Well, angle 8 is going to be what? It's going to be supplementary to angle 3. There's the line that they both share. So they're going to be supplementary, so 180. So first, let's find x. We, what do we do? Subtract 9x from both sides to get that equation. Then we add 1 to both sides to get that. And we divide by 5 to get that. Now we have x. We're going to plug x in to our original equation for the measure of angle 3. Okay? And we do so, and we get 9 times 3 plus 14, which is 27 plus 14, is 41 degrees for the measure of angle 3. So we now know that this guy right here is 41 degrees. We also know that this guy is 41 degrees. Okay? Well, we know that 3 and 8 are supplementary, which means they have to add up to 180. So I just subtract the 41. That is 3, and what's left over will be 8. So the measure of angle 8 is 139. Okay, which angle shows an obtuse scalene? Okay, what do we remember about our terms? Obtuse means one angle. That's too thick letters. Let's make that a little narrower and erase that. Let's go. Obtuse, one angle must be greater than 90 degrees. And what does scalene mean? Scalene means no sides equal. Okay, so which one of these has a angle greater than 90? Well, let's look at this first one. That's going to be 180 in every triangle. 180 minus the addition of 50 and 50 is 100. So this guy is going to be 80 degrees. And we can say, nope, not that guy. Then we look at this guy, 40 and 40. Well, we add those together, we get 80. 180 minus 80 is 100. So we're still an obtuse triangle. Uh-oh. Now we have 8 inches. Well, that means the sides are the same, so we can't have a scalene. So that guy is also no good. Let's take a look at this last one. This next one, we got 40 and 50, which is 90 degrees. So guess what? This guy is also 90 degrees, which is not obtuse, so he loses right away because he doesn't have the right angle. Oh, look at that. There's our obtuse angle, and one side, two sides are different. And in reality, we know that this third side is always the longest side, and so it's different also. This is our answer D. Number 20, given M&P triangle, and it's a right triangle. We can see it right there. So what do we know? Identify the hypotenuse. Well, where you find the right side, go opposite of it. This is the hypotenuse. So the hypotenuse, as defined by these guys here, first thing we can see is a hypotenuse is not anything that says angle on it. It's always going to be a line segment. And what line segment is it? It's line segment MP or PM, and there it is. So A is the answer. Which side lengths could form a right triangle? Remember that a right triangle, we have A squared plus B squared equals C squared. And the longest side is always C. The longest side is always C. So 1 squared plus 1 squared equals 2 squared. Okay. Well, 1 squared plus 1 squared is just 1. I'm going to move this over to the right and just continue this on. So that one would tell us that 1 plus 1 is equal to 4, and that's not true. So this guy is not one of them. Let's try the next one. We're going across. Let's try 8 squared plus 15 squared equals 17 squared. And if we did that calculation, that'd be 64 plus 225. Is that what it is? Let me do 15 squared on my calculator here. Yep, 225. You add to it 64. And you get 289. And does that equal the 17 squared? Why, yes, it does. 17 squared is 289. So this guy gets a check mark. Yes, he does. Let's try 18 squared plus 24 squared equals 30 squared. Well, 30 squared is what? 900. 30 times 30 is 900. Let's try 18 squared. 18 squared is 324. What's 24 squared? It's 576. Add those together, do you get 900? Yes, you do. So that guy is also. Let's try 5 squared plus 9 squared plus it equals 10 squared. If we try those guys, we get 25 plus 49 does not equal 100. No, it does not. So this guy is not 1. How about 12, 13, and 14? 12 squared plus 13 squared equals 14 squared. 12 squared is 144. 13 squared is 169. And 14 squared, I don't know off the top of my head, is 196. Well, that's obviously, those two numbers added together is way over 200. So that's obviously not true. So this guy is not true. Let's try the last one here. 20 squared plus 25 squared equals 30 squared. Well, 20 squared is 400. 25 squared, I think is, 625. So my marker, stop. There we go. Plus 625 equals, well, 30 squared is 900. Well, look at that. That's bigger than 900. So that guy also is not it. So there's only one answer, and that was it. 22 and 23, find the value of x. That's what we're doing here, finding the value of x, rounding to the nearest tenth if necessary. So this is just 22 and 23. So we're going to do a squared plus b squared equals c squared. And remember, let's do this in red. This can be a or b, and this can be a or b, but the long side, the side opposite, always is c. So we use 4 squared plus 6 squared equals x squared, 16, 36, x squared, square root of both, you get approximately 7.2. Let's do it on my calculator. Square root, 7.2111, and so this 1 does not make that number jump up, so we get 7.2 as our answer, 7.2 rounded. How about this guy? Next one. Let's take a look at the next one. Let's do it in green. We can have this as A, and this is B, and this is C. Remember, C is always the one opposite the square. Okay, and it always happens to be the longest line. Okay, so we got x squared for our A, 19 squared for our B, and 23 squared for our C. You can see that 19 squared is 361, 23 squared is 529, so we got x squared. We're going to subtract 361 from both sides, and we get x squared equals 168. Then we're going to take the square root as a second step of both sides, and the square root of 168 is not 13. The square root of 168 is, square root of 168 is equal to 12.96. The 6 makes the 9 become a 0, and that also rolls over this to be a 3. So that's where we get 13. 24, 36. Now we're not doing the instructions for 22 and 23. We now have a word problem. We're just doing the word problem. We've got a 36-foot long rope. It's tied from the top of a pole. So here's my pole. I'll draw the picture. Here's my pole. And here's my rope in red. There's my rope in red. And the stake is 17 feet from the base of the pole. So we know that the stake in the ground is 17 feet out. Okay? So we look at our right triangle. We know that this is our C. These two can be A or B. Okay? And let's go ahead and do that in green. Or let's highlight it. A squared, which is we're substituting X. 17 squared, 36 squared for B and C. 17 squared is 289. C squared, 36 squared, 1296. Got the square root of that. We subtract 289 from both sides. We get 1007. We take the square root of both of those, and we get 31.7. Notice that it says round to the nearest tenth, and we did. Okay. Starting from the line of scrimmage, Trey ran 25 yards, so there's his 25-yard run. He directly down the field, then turned to his right and ran 8 yards. How far is it from where he started? So how far is the hypotenuse here? Okay, so now we know that we've got A squared plus B squared. We can go A, we'll do A up here because that's what they did. Then B here and C there. So our A is 8, our B is 25, and our C is the X value. Multiply those out, you get 689, square root of 689, 26.2. Label it with the correct yardage. Find X for number 26. So we're finding X. We have a right triangle. We're looking for, we don't actually have a right triangle. What we have is a series of lines. The only thing we know is what's given to us. So let's go add this in here. There's a 90 degrees. What do we know? Let's take a look at this spot right here. We don't know that spot to begin with, but we do know that it has to add up to be 180 degrees. And so 180 minus 98, which came from right there, gives us 2 and 8, which is what that is. That says 82. It's hard to read, but that's what that says. It's 82 degrees. So now we know that this is 90 down here. We know that's 151 and that's 82. So how do we know this from that? Well, we know that any quadrilateral has an interior of 360 degrees. So we take 360, we subtract to it the 151, the 90, and the 82, and we end up with 37, and that is our answer. Find the measure of angle A, number 27. Angle A is right here. Once again, we know we have to calculate something from this one. We use vertical angles to get that. So let's go look at this guy up here. We're going to look at the blue area first. We have a right triangle. So we have 180 degrees. We know that one of the angles is 38. We know one of them is 90. Those add up to be 128. We know that the total has to be 180, so 128, and that gives us our 52, and that's where that 52 come from. This 52 exists because that's the vertical angle partner to the other 52. Now we have a quadrilateral where we know 3 of the sides. We take that 360 and minus, because we know 360 is how many degrees inside interior angles of a quadrilateral, and we minus all of those things, and we end up with 121. Fill in the blank. A rectangle is not always a square, but a square is always a rectangle. A rectangle is never a parallelogram. I take that back. It is sometimes a parallelogram, but a parallelogram can still exist and not be a rectangle. So a rectangle is not always a parallel. It is not always a parallelogram. It is always a parallelogram. A rhombus is a slanted square, so it can't be a rectangle. And a quadrilateral can be many different things. So the only answer here is A. A rectangle is not always a square, but it can be. A parallelogram is always what? Is it always a square? Well, it doesn't need to be, but it can be. But it is a square is a parallelogram, but a parallelogram isn't a square. Is it quadrilateral? Well, yeah, it's always a quadrilateral. Okay. Is it a rectangle? No, parallelogram can be slanted on the side, not have right angles. And the rhombus, the definition of rhombus is a four-sided figure without 90-degree angles. So the only one left is B for quadrilateral. Shape below, all the names that apply. Is it a quadrilateral? Yes, it has four sides. Excuse me. Is it a trapezoid? No. It has four 90-degree angles marked right here. Each of those means it's 90-degree angles, which means this is parallel, and this is parallel, and this is parallel, and this is parallel. So that's what that means. So trapezoid can only have one side of parallel sides, so it can't be an isosceles trapezoid. It's a parallelogram, just proved it by showing you the parallels. It's a rectangle, by definition, 90-degree and parallel sides. Rhombus is a slanted square, so it's not a rhombus. And it's not a square because it's obvious that the sides are too long and they are not marked for us. Classified number 31, is it a quadrilateral? Yes, it's four-sided. Is it a trapezoid? Yep, definition trapezoid, two parallel sides and two different sides. I didn't mean to do that way. That should not be marked like that. We don't know. And then two sides that are not parallel. Okay, is it an isosceles triangle? We don't know that. That's kind of the trick there. We don't know if this side and this side are the same because they didn't give us the little tick marks to tell us. Is it a parallelogram? No, you got to have two sides of parallel sides for a parallelogram. Rectangle has to have right angles. Rhombus has to be two sides of parallel, all the same sides. Square is 90-degree angles, doesn't have them. So top two is all we get. Eliza drew a four-sided figure with opposite sides parallel and congruent. Uh-oh. Four-sided figure with opposite sides parallel and congruent. Notice that it doesn't tell us that all four sides are parallel and congruent. It just says opposite sides are parallel and congruent. So is it a quadrilateral? Yes, it is. But is that our best answer? I don't know. It'd be lower in the thing. Is it a parallelogram? Yes, it is. We've got opposite sides parallel and congruent. Is it a rhombus? No, it is not a rhombus because that has to be opposite sides or it has to be not 90-degree angles. And is it a square? Well, it has 90-degree angles, but we don't know if the sides are the same. So the best answer here is parallelogram. A rhombus with four right angles can be best described. So a rhombus is any four-sided figure where all the sides are the same and parallel. Opposite sides are parallel. So now we have the same drawing as we had over here, but we do know that the opposite sides are the same. Four right angles can be a rhombus, is the definition of four sides. So that guy is going to come all the way down to a square as the best answer. Find the sum of the measures of the interior angle. Well, the sum is equal to n number of sides minus 2 times 180. So a nonagon, if you remember, is 9. So 9 times 2 is 7. 7 times 180 is 1260. Measure of angle y. Where is y? Right here. We're looking for the measure of angle y. We have how many sides? 1, 2, 3, 4. We can call it 5 and 6-sided figure. Okay, after doing some manipulation with that square, we get this degrees, this 62, which tells us the opposite side, which tells us this 118. This guy is gotten because we can tell that 128 and 152 have to add up to 180. It's supplementary. So now we have all of our interior angles defined, except the last one. We then take our formula and we can check to see if the total has to be 720, and we subtract all of these degrees that we know, and we end up with 139. Here's the diagram below for 36, 37, 38. Find the measure of angle E. Here's angle E, and we are told that A, B, C, D, okay, A, B, I'm going to just draw a quick reminder arrow that it goes that way, is equal to EF. So this is the direction we're going. So, measure of angle E. Angle E is equivalent to angle A. Angle A, let's highlight that with yellow. There's angle A, angle E. So angle A is 94, so E is 94. Now let's take a look at the measure of angle G. Angle G is right here, and its partner is, G is the third one, so its partner is C, which is 89. But how did we didn't know 89. We had to use our 360-degree rule for quadrilaterals, subtract all the 91, the 94, and 86, and we end up with 89. So we can tell that G is also 89. And finally, we get the side length GH. So GH is the last two. So that's CD. So GH right here is the same as CD, and that's labeled at 20. So we get 20. 39 through 42, graph and label. They graph for you right here. This is our original. And we're reflecting across the x-axis. So reflecting across the x-axis, we come down 3, add 3 more, and that's our C prime. B, we come down 6, 6 more, there's B prime. A, we came down 8, and 8 more, A prime. And D, we came down 5, 5 more, D prime. Okay? Take a look at trapezoid. There's our trapezoid up here. We're asked to translate +3 -7. So +3 is going to go right. -7 is going to go down. And that's how we end up with that guy. Everything stays the same, just goes +3 to the right, -7 down. Quadrilateral, JKLM, right here, JKLM. There's our original. We are rotating it. So we are rotating it. Notice they don't say clockwise or counterclockwise because that always goes the opposite corner. So if we say that, we operate that, and we go like that around. We follow the correct rule, and we end up with the opposite sign. So this K, let's just take a look at K. K was originally -1, comma, -2. And what does K end up being? 1, 2 up here, just opposite signs. So K is 1, 2, and it was originally -1, -2. Now we're going to do a scale factor, triangle on a triangle. There's our triangle, TUV. Our scale factor is 5/2, which means it's going to be an enlargement. So we just multiply by 5/2. Let's just do T first. Let's just do that one by hand. T, the x value of T is 4, 0. So let's take 4 times 5 divided by 2. So 4 times 5 is 20 over 2. Simplify that to 10. So T jumped all the way to T is 10, but 0 multiplied by anything is 0, so it stayed on the same line. So that's why T is 10 comma 0. And then you do the same thing with the other ones, except the other ones won't be on 0, so you have to actually do the X and the Y coordinate, and that's why you get those. 43, identify the type of transformation. Well, what transformation did we do here? Well, this one, we see we come here and we didn't reflect it. It's not straight across, so it's not a reflection. It must be a rotation. It must be a rotation, and if we rotated this direction, remember, here's a clock. This is the way the clock hand goes. That's clockwise. This is the way the clock goes counterclockwise. So which way did we go? Well, we can either say we went clockwise, 90 degrees, or we can say we did counterclockwise, 270 degrees. So this is either 90 degrees or 270 degrees counterclockwise. So it's not a reflection. We've already decided that. Is it a rotation counterclockwise? Well, we looked at it. It's a clockwise rotation of 90 degrees. Well, that's not right. Well, this one's counterclockwise, so we're not using that. So counterclockwise 270, yep, there it is. That's a D. What about this rule? Well, you see that M is still in the same position, so this must be a translation, must be a move down and over. So let's see if that works. Let's see if we use, let's just do P. If we came down to there and over to there, does that work? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9. Down 9 is minus 9. 1, 2, 3, 4, 5, 6, 7, 8. Minus 8. So it looks to me like this is a translation. Minus 9, minus 8. Did I count it wrong? They say A here, so I must have counted wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I know what I did. That's the up and down, and that is the Y value. This is Y, and this is the X. So I would have got that one wrong, but I would have corrected myself by looking at it. There's the right answer. It's minus 8, minus 9. So there we go. Now let's take a look at 45. Show the graph of dilation factor of scale of 1/3. So how do we figure out that? We look at them and we take a letter of just S. Let's take S. We're always starting on S, right? So we'll just do S every time. So S. Let's do R because it's right on. Let's do R because it's right on the X-axis, right? Okay. So we're looking for a 1/3. Okay. So first of all, 1/3 means a reduction. So it should be smaller. That's R prime. Oh, it's hard to read. Okay. I'm going to make this a little bigger so you can see it. This one's R is the small guy. So it can't be this guy because the scale factor would have been 3 or bigger, been bigger. How about this guy? Here's my R on letter B. So the R prime is the reduction. So is that a possibility? Here's R prime. That's an increase. So that can't be. And here's R and R prime. Where's the prime? Yep. You can't see it on that R, but you can see it on the S and the T. So this is a reduction. So the only possible answers are B and D. So if we take a look at R, it is at, let's see if we can count this. If this is the X-axis right here, there's the origin. We're coming back 1, 2, -3, 4, 5, 6. So R is 0, 6. And let's make that a little smaller. All right, let's write that again. R is 0. That's -6. Yeah, let's do it right. -6, 0. Our Y value is 0. Okay? Now, over here on this guy, same thing. Well, no, we don't. We got 1, 2, 3, 4, 5, 6, 7, 8, 9. R over here is negative 9, 0. Okay? Well, what's R prime? On this guy, it's 1, 2, 3, negative 3, 0. And on this guy, R prime is negative 3, 0. So which one of these were multiplied by 1/3 or divided by 3? This one was not, so we can cross that guy out, and our answer has to be this guy, divided by 3. Negative 9 divided by 3 gives us 1/3. Now we got a bonus. We got to do a lot of figuring. It says find each angle measure. We have parallel lines, so we have a transversal, and we have parallel lines. So we have 2 sets of transversal, and we have a right triangle. So a lot of things can be figured out. Let's just do that right triangle right off the bat. We know that that's 90 degrees. And if that's 90 degrees, we can tell from this guy, this pair, I have to add up to 180. So M has to be 42. Okay, so now if this guy right here is a parallel line with this guy right here, and 138, let's see, 2 corresponds with 7. 2 corresponds with 7. Oops, I want to do that in green. 2 corresponds with 7. We know 2, we know 12, right? And 2, if this is our transversal, has a vertical of 4. So that tells us all of the guys that should be 42 degrees. 4 and 7 and 9, 12. Okay, now let's take a look at the rest of them on that set. If that's 138, then this guy's 138. Then those 2 have to add up to 138, and those 2 have to add up to 138. So we know that 3 is 138. And we know that this guy, whoops, go right here in red, that guy has to be 138 minus 77. And so angle 6 is going to be 161. Is it 61? Yep, 61 degrees. So now we know that that guy is 61 degrees. Now we know that 4 is 42. If I can write it. And 61, and we know we have a triangle right here. So we can make 5 equals 180 minus 103. So hopefully that's 77. Angle 5 is 77, and there it is. Angle 5 is 77. Okay. All right. What else would be 77? Angle 8 right here is vertical with that angle. So angle 8 is 77. We know angle 6 is vertical with 11. What else do we know? We know that, these 2 lines, this line and this line are parallel. So 8 and 11, or 11 and 10 are alternate interior, which are congruent. We know that number 9 is, what do we know about number 9? We know that it is 42 degrees because we know 8 and 10, and we know 12 is 42 degrees. And if this was a parallel line, okay, can't tell from that, but we can tell from the 8 being 77 degrees, 10 being 61 degrees, 77 plus 61, 8, 138. 180 minus 138 gets us 8 and 38, 48. Did I do that right? Oh, I obviously didn't write it right. 138. There we go. Comes out right now. That becomes 42. 180 minus 1 and 2. This guy is 42. So there's 9 at 42. Okay, now we got to figure out 13, 14, and number 1. Where's number 1? Well, we know number 2 is 42. We know 90. 90 plus 42. We're doing number 1 now. 90 plus 42 is equal to 132. You'd have to add 48 to get to 180. So this guy is 48. And angle 13. Well, let's figure angle 14 right there. Supplementary. 180 minus 62. So angle 14 is going to be 118. There we go. And then we take our 3 angles here. We know 12 is 42. We know 14 is 180. So 118 plus 1 plus 42 gives us 160. Leaves 20 left. And there we've got all the sides.